So welcome to the last part of this session on secure software engineering, looking at the late phases of secure software, namely specifically on secure deployment, security response, metrics. You don't need to take care about this. I will just tell you a few sentences about this to be complete about it. And code protection, some information on code protection. That's the agenda. The most important thing to remember is that anything that you do in the deployment phase and goes wrong can actually make everything that you've done before useless. So don't think you're finished with the product, with your coding and the testing. You're finished when it arrives securely at the customer side. That's when you're finished, not before. So therefore, you need to take this phase also into account. The life cycle includes regular maintenance work, so you should also think about what happens when the software is already there. So developers should know about the usage of their software. So they should not limit themselves to the requirements of the user, but also to the context or where software is later on used. Regarding operations, regarding relationship between design, development, and test, in view of ITIL, for example, or another requirement, security demand of the underlying operating system. So sometimes you cannot install an application securely on a specific device because the specific device has an insecure operating system. So for a long time, you wouldn't install a very confidential app on an Android phone because the Android operating system would still allow other apps to ask this app for specific information. Now the sandboxing is done, so that works no longer, but nevertheless, this should be taken into account. So what should you do in software deployment? Software deployment are all activities that make software available for use in a productive environment. The general deployment process consists of several interrelated activities with possible transitions. Every software system is unique. The precise processes within each activity can hardly be defined. Therefore, deployment should be interpreted as a general process that has to be customized according to the specific requirements of your customer, of the software, of the tools, and so on. But there's a general guideline what you need to do. Here are the phases. These phases, these are sub-phases of the deployment process phase, so to say, and these are the phases that are defined in the ITIL, so in the IT infrastructure library. You know ITIL? Does that sound a bell? No? IT infrastructure library, mentioned this morning already, is a standard, is ISO 20000 in the meantime, is a standard for managing IT services. So if you are going to work in connection with organizations that professionally deploy IT services, then you should know what ITIL is, either as a requirement from an engineering point of view or as an operational condition if you're going to work there. And this structures a number of processes. There is the deployment process, there is a deployment process specified in ITIL for IT, and these are the phases of that deployment process. So it's release. Release includes all operations to prepare a system for assembly and transfer to the customer side. So making a product out of software. So there's software finish and you create a product. You, like in earlier days we would say we burn the CD, or we no longer burn CDs. So there's a virtual step, so to say. The next step is installing the software into a new or existing system at the customer side, or in the cloud, or in the service provisioning. Installing is not activating, so installing the software is there and ready to run. Activating is running it the first time with initial configuration, maybe also with integrating or adding user data of that specific customer, or the product data if it's a sales site, sales web page, for example. Then there's adaptation, so modify the software to the specific needs of the customer. There's a big part in SAP implementations. And finally, later on, there's the update process where you may actually replace the software again by a new version. Nevertheless, in that update process, you shouldn't destroy the old data that you gathered. So the update process must be, so to say, destruction-free. So what are the security duties? So what should you do security-wise? So the release manager, so that's the person who is responsible for the release step, should enforce quality and security aspects, secure software in the production environment, remove debugging, remove default users, remove backdoors, remove install scripts, maybe do some final source code review. That's the phase, actually, the release phase, where Microsoft has its security push activity happening. Risk assessments could be done for a last time, manage dependencies to enterprise security management. Maybe you need to integrate information about the system into other systems, perform some awareness training, and so on. Securely transfer the software to the target environment. You all know probably that when you run Microsoft or Apple, there is software signature happening. So you cannot install software from other sources to these devices except you explicitly allow this. This assures, the reason is you would like, obviously one reason is to restrict installation of any kind of software, because Microsoft wants, and Apple want to have a handle on what's installed on their devices and maybe also gain some money with that process. But the security reason for this approach is that we want to avoid that a manipulated version of software under the correct name is going to be installed. So, for example, you probably know VLC. You know VLC? This is a video player, and the VLC video player has been for some period of time a source for Trojan horses. So it was manipulated in such a way that the real VLC was, say, there were added additional functionality for hackers. So VLC could have signed its software so that the manipulation would have been discovered. So if the software is changed, the digital signature wouldn't work again, and so the user or the operating system would recognize, this component has been manipulated, this is insecure, I won't install it, I won't do this. Unfortunately, VLC didn't participate in the software signature program, code signature program of Microsoft. At Apple, currently, the current setup for the macOS, for the desktop operating system, is if you are not an administrator, you cannot allow the installation of software which is not signed. Doesn't even work. Gone. Cannot even do this. You can still install software from other sources, but the key for signing must come from Apple. So there must have been an initial contact between the manufacturer and Apple. So this is generically speaking a very important step, because if in the transfer of the software to the customer, if you manage to manipulate the software at this late stage, well, it's very easy, right? So you can manipulate download pages, for example, where you look for the software. You manipulate the download links, for example, so that people start downloading from the wrong source and so on. So this is really important. So therefore, I very much recommend, if you're working with online software, with software that's installed on devices, use code signature. More information. Secure configuration. So setting up your software initially requires secure configuration. I spoke about that secure switch yesterday. This falls into that category here. So you should have the ability to configure your software securely. Some vendors make it easy. For example, Apple, I must say, and Microsoft as well. If you're starting the operating systems from the beginning, now they're configured in a pretty secure fashion, and you need to open up things if you want to do more. If you want to install your own web server, to be accessible, you need to open the firewall and open the port. Same for Microsoft. But that wasn't the case all days, and still the large software manufacturers have big problems. SAP, for example, delivers software in an insecure manner. So if you install it and run it like it is, it's full of vulnerabilities, mostly configuration vulnerabilities. And then to secure it, you need a handbook of this size, 2,000 pages for locking things down. I don't think this is user-friendly. Because who's going to read these 2,000 pages? Nobody, right? So no, not nobody. There will be people reading 2,000 pages in banks and stock exchanges maybe as well, but not in general. So therefore, I would recommend you and urge you as developers, think about the moment in time where your software is going to be installed on the customer side or used or whatever, and allow the users to make an easy, secure configuration. Either it's secure by default, which is actually, I think, also state of the art, or at least that it's easy to configure it with, I don't know, 5 minutes configuration, no longer. Yeah, software activation is also a step, but I skip this. This is not so important. Software adaptation. In SAP, by the way, this is here the big SAP customization activities happening here. In SAP, 2/3 of the vulnerabilities are created by consultants that are developing additional functionality for SAP. 2/3. So most of the vulnerabilities that you find in SAP are not created by SAP. They are created by consultants. They are like Accenture and so on, when they're actually implementing additional functionalities because customers want them. So therefore, you should also be able to control this process. Now to a very important step. Your software is now out. Software is running at customer side, or your website running for half a year. You switched your teams. The teams have been successfully delivering. You made a party. Well, yeah, great success. New product out. 2,000 users. Everything's great. The teams the people are distributed to the new teams, the new products that are out there, and then a researcher sends you an email and tells you, I found a serious vulnerability in your software. Not only I can hack your software, but your software allows me to hack the customer system. What do you do? Big problem. Probably, as I've seen in some organizations, people first say, oh yeah, we're too small. Who cares? Until the first customer calls, and I have a problem here, a serious problem. I cannot recover my data, and I cannot close this security issue. I need to turn on the system so that I can work. This is not what I wanted from you. I'm going to blame you, and I'm going to get my money back from you. I'm going to claim all the damages in a court case. So be better prepared. Since you cannot avoid there's no 100% security, so there will always be vulnerabilities in software, even in your software, even if you're excellent developers and security-minded people, you would still at some point in time leave something in that you don't know, and that is in there. So you should be prepared for the moment that this happens, right? So what to do? That's about security response. Security response originally comes from Computer Emergency Response Team or Computer Security Incident Response Team, and is the product part, so to say, of the CERT activity. And security response covers communicating to the users of the software what to do in case of a vulnerability, fixing it in which priority and which order, and communicating the patches and other ways of solving the problem. I'm especially saying other ways of solving the problem because in many cases you cannot patch for many reasons: compatibility issues, functionality issues. The patch would destroy other data that the customer doesn't want to keep. So it's a real serious problem. It's the best practice, so it's adopted by several software manufacturers. Microsoft does it, Apple does it but doesn't speak about it. Even IBM and SAP does it. So it's really all the big ones do it. So I explained this already. There's no bug-free software, especially there's no 100% secure software, even if you did a pretty good job. So fact is there will be a security critical issue in the software. So first, fixing. Fixing comprises 4 steps. You need to understand the issue, the impact and the root cause. You need to have mitigation, so solutions for the problem. You need to prioritize. So maybe as the small company you're working in, there's only one issue per year, so you don't need to prioritize. But if you're in a big organization like I don't know, an SME producing 20 products, then you may have to prioritize for handling the issues. Whom are you going to save first? Who are you going to save first? And actually, of course, the fix. The easiest, and that's interesting, the easiest fix is fixing the code and issuing a patch. That's the easiest thing. The configuration is somewhat easy, but often has side effects. So specific customers are using specific services or specific conditions, and if your configuration fix, so to say, changes that the software may not run anymore at the customer side. So depending on things that customers may change is difficult. It's not as difficult as others, but it's rather difficult. The fixing design is hard and costly, so you try to avoid fixing designs, as we explained today, as much as possible. So you try to avoid them from the beginning, but even if they occur, still it should and finally you still, if you don't have any other solutions, you may say, okay, I'm not able to fix a problem in the software. We need to find something outside that closes the attack surface, which makes it impossible for the attacker to use it. Security issues, okay, you know this. This is specifically for developers. And a security response process is a standard software maintenance process. The standard software maintenance process is typically optimized for fast issue closing, is centered around the manufacturer responsibility. Standard software maintenance processes do not allow for examining the customer's risk. So again, we are with risk, but this time it's not a risk for the software. This time it's for the risk of the vulnerability in the customer context. So what does it mean for the customer? What could the damage be, and how easy it is to make use of that vulnerability? They don't listen to security researchers. So what actually you need to do is need to get in contact with that person, right? So that called you and said, I have a security issue, or sent you an email. You need to talk to him because you need some information from him. You need to understand how did he achieve this and what did he do to be able to fix the problem. So you cannot say, I don't speak to hackers. You need to speak to the hackers. You need to listen to them. Some organizations make even a business out of this. So they put up contests. So they have hacker contests, bug bounty programs, it's called, where hackers can actually submit their hacks and get some money reward or other type of reward, typically money. It's a big issue, big problem today. You can even buy security vulnerabilities found by hackers on platforms. So there are hacker platforms. One in Switzerland is closed by now, was the biggest one back at that time, a couple of years ago. Was called Wabi Sabi Labi, and you could offer your exploit and your vulnerability on that platform as an auction. So you can tell, I have a zero-day exploit for iPhone iOS 11 free. I can listen to the camera. I can watch the camera, listen to the whatever. Who wants to have it? What are you ready to pay? Guess a side question. What do you think? Such as I described it, such a zero-day exploit would actually achieve in the market. A value of a zero-day exploit, not taking over the iPhone, but being able to serve as a spying device. What do you think? How much money would be organizations ready to pay for this? Approximately, spying capability of an iPhone is about $1 million US dollar, more or less. It might be a job for you as well. Right now, if you're in the security business, you'll get a little bit more experienced, and then you develop exploits. You're good developer. Actually, as I mentioned, I think in the initial presentation, these dedicated hackers are typically excellent programmers. So, if you're an excellent programmer, there's another way of making money. Okay. Actually, I would recommend to implement a security response process dedicatedly, but it must be integrated with the other processes, which makes it a little bit hard. Anyway. Security patches shall be separate from standard patches whenever possible for a number of reasons. I won't go into detail for timing reasons, but they definitely should be delivered separately. So you must be faster. You cannot wait for the next standard patch in 9 months to be delivered. You need to issue the patch now if you have a solution. And you should test it definitely, and you can read this. This is what I mentioned earlier. So trading vulnerability information is dangerous. There are platforms where vulnerabilities are traded. But I think we cannot go back. Now this market is open, and there's a multi-million-dollar market year by year, and you can look up and research a little bit what you can find. The biggest hacking financing institutions are, what do you think? Who's financing most of the security vulnerability development through such an activity? No. Interestingly, but no. They have experts, they analyze this, but most of them don't develop exploits. National security agencies, NSA and co, we call them, whatever country, all over the world. I'm pretty sure Tunisia plays a small role, but also plays in that game. So we are currently in an information war. the more vulnerabilities, the more exploits a country has, the more powerful it is on the cybersecurity side. So, yeah. So now you had the fix, so you found a solution, maybe you have a patch or you have another solution, you developed an idea, how you can help the customer. How do you communicate? Will you just Twitter it? We have a security issue, here's a new patch. Or what would you do?
Validate the solution. Validate the solution.
Well, okay, so it's validated. And now you need to communicate. How do you tell your customers? So, okay. So if it's a really, really serious problem, it's more important for the customer to know that there is a risk and there's a problem than to have a solution. So don't wait with the communication until a patch is available. If it's really serious, tell the customer right away. Say, here's a problem, I don't have a solution right now, I'm working on it, I come back to you as soon as possible. So that's the first one. The communication shall be, or the speed of communication should be tied to the risk, not to the availability of a solution. Right? So that's the first one. Second, inform customers. So my personal recommendation is you should know all of your customers, and to be prepared, you should have email addresses, telephone numbers of those people that you need to contact in the case of security incidents. So that you have a mailing list where you can send out directly to those people and not go to public. So what Microsoft had a big problem when they started this Patch Tuesday activity, where they every Tuesday communicate the new patches and new security fixes they have, and even security vulnerabilities they don't have solutions. They discuss on this Patch Tuesday call. It's every second Tuesday a month. You can call in. There are 100,000 people calling in. You can call in yourself as well if you want to. I forgot what I wanted to say. Yeah. So you need to communicate directly to your customers. And Microsoft had a big problem. Namely, they didn't know their customers. It wasn't necessary 10 years ago to register when installing Microsoft Windows. So they didn't know whom. The only thing they could do is go public. So that's the reason why we have this approach to go public. SAP, you never hear about SAP talking publicly about security vulnerabilities. It's all directly to customers, directly low level, here, it's not discussed in public, right? So therefore, these are called vulnerability disclosure strategies. When do I disclose my vulnerability? Therefore, vulnerability disclosure. Full disclosure is I tell everything, I tell how the attack has happened, and I tell it to everyone. That's the open source approach. The open source community says, hey, we need to publish everything. I don't think this is a good idea because it also helps attackers, right? Responsible disclosure is I'm thinking about whom to tell, I'm telling about a risk, I'm telling about how to fix it, but I'm not going to tell how to make use of it. That's responsible disclosure. And then we have no disclosure. That's something that Apple did for years, until maybe 2010, 11. They're not even telling customers. They're not even making aware that there's a security issue, and now there's a security patch, and there's to solve the problem. They don't tell anybody. Didn't tell anybody. There are vulnerability description formats. So today, CVSS, CVE, CWE are the standard ways of dealing. This looks like this, for example. So it is a typo-free. Typo-free is a content management system often used at universities and public domain organizations. And so you see how this is structured somewhere, and you could look a little bit deeper if you want to. A security response policy is then the policy that describes how your company is going to handle all this. So how to communicate, when to fix, when to do this, when to do that, when to do that. Okay, so let me stop here for timing reasons and switch to the exercises. Write a secure deployment checklist for your application. So you have a website that you sell. You're having a website that you sell, more or less. You have an app that you sell. Write a security checklist that users or administrators should follow to install and run your software securely. What elements need to be configured, what elements need to be installed, provisioned, whatever you need to do to run it securely. It's okay, it's a one-pager, must not be long, but should be something concrete and realistic. For your application, describe your vulnerability scoring mechanism. So how would you score vulnerabilities? So there are a number of scoring models like CVSS. I mentioned OWASP Top 10 as well. So look up what you think is the right approach. For you, choose it and describe it. And describe your disclosure policy. So how and in which way would you disclose vulnerabilities? I'm leaving out the second to last, develop 2 security metrics. You don't need this one. But I want you to have the last one as well. But this needs to be researched by yourself. Which code protection measures would you implement for your system? So how would you protect your code from manipulation and maybe also theft? Okay? Now, regarding of time, it's 16:52. I'll stop the presentation here, and then we talk about the date where you should deliver all this. And